Okay, so we have our next topic, which is complex variable applied to analytic geometry. So this is just simply the imaginary number, or it also can be denoted by I or sometimes J. Okay, so we have here the plane, which is the complex plane, and also called Argand diagram. So let's say that we have here the point, we have here the point Z that represents x plus yi. Okay. So of course, the x-axis or the real axis will be your x, and your y-axis now will be your imaginary axis. And then, if you want to get the magnitude of this point, all you have to do is just take the Pythagorean of the triangle that you will be able to form. So you'll have here the model equation, which is z equal to x plus yi, or z is equal to x plus jy. Either of the two is fine. So your z will be your complex variable, x will be your real component, y will be your imaginary component. Your I, or the imaginary unit, that is I represents the square root of -1, or it is also equal to -1 raised to 1/2 or -1 raised to 0.5. Okay? So for the magnitude, that will be your z is just equal to r, or the x square root of x squared plus y squared, to get the magnitude or the modulus. Next, for the theta, that will become just the theta is equal to the arctan of y over x. This is also called the argument. So if ever that you encounter a problem that you are asked to find the argument, that simply means that you are required, the problem is requiring you to find the angle. Okay, so let's try number 1. So for number 1, we have identify and find the equation of the curve represented by z minus 2 equal to 4. So these lines, it represents that you only need the magnitude of this one. So you have to get the magnitude, or what we call the modulus. Remember that z, okay, that z is equal to, replacing this one, you'll have here x plus x plus jy minus 2 equal 4. Okay, and then grouping all the terms that doesn't have j and the ones with j, you'll have here x minus 2, and then plus jy equal to 4. So if you want to get the magnitude of this one, all you have to do is just to take the Pythagorean of that. Okay, so you'll have your square root of x minus 2 squared plus y squared equal to 4. If you will square both sides to eliminate the square root, you'll have your x minus 2 plus y squared equal to 60. As you can see, we have x minus 2 squared plus y squared, and they have the same coefficient. Therefore, this is already the equation, and then by identifying that equation, that is now a circle. So that is the equation, and identifying that curve is a circle. For number 2, you'll have here. So for number 2, so identify and find the equation of the curve represented by, we have here z minus 3 minus z plus 3 equal to. Okay, so the steps are just the same. So you'll have here x plus jy minus 3, and then minus x plus jy plus 3 equal to 4. So getting groupings first, okay, group first the imaginary and the real part, plus jy minus plus 3, and then plus jy equal to. Okay. So getting the modulus, so you'll have here the square root of x minus 3 squared plus y squared. And then square root again of x plus 3 squared plus y equal to 1. Okay? So all you have to do is just square both sides here and you will be able to eliminate the square root. So I won't be um, solving this algebraically anymore, but I can give you the answer. Actually, this is really easy. If you see that this is negative, okay, then it is already a hyperbola. If that is positive, of course, that will be an ellipse. Therefore, the answer for this one, it should be a hyperbola. Okay, okay, so for number 3, we are to identify and find the equation of the curve represented by, so we have here said that im z squared equal to 4. So what does im means? Im means is the imaginary part. Therefore, what we will do here is we will just get the imaginary part. We will be neglecting the real part. Okay, so let's try to get, as you can see, we need z squared, right? But z is equal to x plus yj. Okay, now if you need squared, therefore you'll be squaring that also. So x plus yj squared. Therefore, you can say that z squared is just equal to x squared plus 2x yj, okay, plus y squared j squared. Okay, but simplifying that, you'll have your x squared plus 2x y j. So j squared is equal to negative 1, right? So negative y squared. So let's group all the real part and the imaginary part. So the real part is x squared minus j squared and plus 2x y j. Oh, no, no. This is y. Y squared. Okay. So what happens here is this part is the real part, and then this part will be your im. Therefore, we can say that the im of z squared is just equal to 2xy. 2xy. So going back to the problem, therefore you can also say that this is 2xy just equal to 4 from here, equal to 4, or xy is equal to. So if you were able to watch the whole series of, or the whole playlist of this video, you already know that this is a rectangular hyperbola. Okay?